Welcome. In this video I'm going to show you how you can perform a Freeman Tukey Goodness-of-Fit Test using R. I'm using R version number 4.3. The packages that are loaded by default are these, and in this video I'm going to show you how you can perform it without using my own library. I have a stikpet R library. I make a separate video for that one. This video will just focus on how you can perform the test, not so much if you should, because there are quite a few different tests that could be used in these situations, and perhaps this one is somewhat redundant. But that's not for me to judge. I'm also not going to explain too much on how to read all the output. It's just about how to actually perform the test. I'm using Jupyter Lab, but the code should also work in, for example, RStudio. I'll need some example data, so I'll load in a CSV file, GSS 2012 from General Social Survey. I slightly adjusted these so that I can use them as examples. And the field that I'm going to be using is the marital status. And just to get a quick impression, we can use the table function for that. And then we can see here the counts for each of the 5 categories. To use some other libraries, for example the MSC Quartets library, you can actually perform a Freeman Tukey test with this one. Of course you will first need to install that package and then you can load it. And once it's actually loaded, there's a power divergence stat function. It does require the expected count, so what we can do is we can simply sum all the counts we've had from the table and then actually divide it by the number of categories, which we can easily obtain using the length functions. So that will give me those expected counts, and then I can use that power divergence stat. Needs to be numeric, feed it the expected counts and set then lambda to minus 0.5. Then we get the chi-square value, which is 1166. The degrees of freedom is simply the number of categories minus 1. And then finally we can use the p chi-square function from our stats library, and it will spit out the p-value, which in this case is extremely low. Now if you don't want to use any other library besides the ones that come with R, again, we'll need the k and the n, the number of categories and the sample size. Again, though, that's expected counts. I'm just going to repeat the same function there. So 388.2. And then this scary formula actually calculates the Freeman Tukey statistic. It's not that complicated. This big E looking thing is the summation sign, so you can simply use sum. And then it's the square root, which is the same as taking something to the power of a half. And you do that for the observed counts and subtract the expected one. So that gives that 1166. The modified version is slightly different, as you can see, but it's nothing different than in the other function. So still just only a sum function and raising things to the power of a half, and all the way at the end there's a square as well. So that gives a slightly different chi-square value. The degrees of freedom is the number of categories minus 1, and of course we can use that p chi-square function again, and we get the exact same p-value. It's possible to do a Pearson correction, which is n minus 1, the sample size minus 1 over n, or a Williams correction, which is slightly trickier, but we have everything in here. We have the k, the number of categories, the sample size, and the degrees of freedom. So we can simply use those, and then you can see you get a slightly different chi-square value. Now for the Yates correction, that's also an option. What you do is you subtract a half if the observed count is greater than the expected count. You add a half if it's less, and you just keep it if it's the same. So that gives us also a slightly different one. I made one big function that has all of them in there. So if you're interested, you can copy that, and then you can just use that function and it will spit out all the values that you wanted. Alright, and that's how you can perform this Freeman Tukey or modified Freeman Tukey Goodness-of-Fit test with R. I hope this video was helpful, and thank you for watching.